If there's one thing we can all agree on, it's that we work in a hazardous industry. Incidents, and sometimes disasters, do happen. We can be very proud of the progress we've made to improve safety across the oil and gas industry. We're on a journey towards Goal Zero, but we won't get there if we don't change the way we think. The fact that an incident hasn't happened doesn't mean that it won't. Every incident-free day that passes might increase the chance of one happening. Why? Because we can get complacent. We stop being uneasy. We stop looking for weak danger signals. We stop thinking, what else can we do to ensure safety? We all do it. We all think it won't happen here, now, to me. But it can. And that's why it's so important to demonstrate your chronic unease. Sounds nasty, but it's not. It's the way to avoid complacency. Chronic unease means noticing those weak danger signals and responding to them in a much stronger way. It means knowing when to think fast and when to think slow, using our expertise to think quickly in familiar situations, but also be able to stand back and take the time to think things through when we need to. Most of us are good in a crisis, when strong signals tell us something is wrong. Our car starts belching out thick black smoke and shudders to a halt. Time to get it fixed. But what do we do when there's a slight rattle? A noise we haven't heard before? Do we pay a mechanic to tell us it's nothing to worry about? No. Most of us hope the rattle just goes away, which could end up costing us more because we didn't fix the small problem before it became a big one. The smoking car was a strong signal. We had to fix it. But the rattle was a weaker signal, and our lack of unease cost us. The same applies at work. We see corrosion where we didn't expect it, or smell something we don't recognize. We might find a pump vibrating in an unusual way. We see a new colleague looking puzzled over a vital piece of equipment. A meter is giving an unexpected reading. Or our well shut-in drills are taking longer than expected. How do we respond to those signals? They don't necessarily mean something's wrong. Nothing's exploded. But it might. The point is to be uneasy and recognize that they might be important. Acting on weak signals is the sign of a highly reliable safety culture. People who demonstrate chronic unease detect, investigate, report, and fix small problems, even if they end up triggering false alarms. Better a false alarm than a catastrophe. They also understand that the barriers and defenses that we rely on should be independent of each other. So if they see signs that a barrier isn't working properly, they don't assume it's not important because other barriers will work. Every single barrier is important because it helps prevent an incident and is there for a purpose. And we have to be alert to signals that tell us our barriers might not be strong. An unexpected test result which suggests that equipment isn't working as it should. A variation from good practice which has become tolerated. Noticing that a colleague is distracted when they should be monitoring a critical process. Or even a decision to carry on that we think was made too quickly. Whatever they are, they can lead to something big and bad. All of us make mistakes. It's part of being human. It's not because we're stupid. It's just the way our brains work. Which line is longer? Our brains can't help but get that one wrong. The lines are actually of equal length. But our brains work quickly to see things in 3 dimensions. They make assumptions to make immediate sense of what's in front of us. Our fast-thinking brain goes for the obvious option. But if we give our brain time, it'll find the right answer. But we like to think fast, and we naturally jump to conclusions. What's the answer to this sum? Easy. We know it immediately. We used our fast-thinking brain. But try this one. It's tough. Our slow-thinking brain has to really engage and work hard. We're tempted to give up. To get it done, we have to stop what we're doing and make a real effort to work it out, to think slowly. Now try this. Together, a bat and ball cost $110. The bat is worth $100 more than the ball. So, what does the ball cost? $10. Easy, but wrong. Our fast-thinking brain jumped to a conclusion, but it was the wrong one. In fact, the ball cost $5, so the bat cost $105. Add them up, and we get the right answer. Our slow-thinking brain, when it takes the time to do the maths, gets it right. But most of the time, our fast-thinking brain is in charge. When it comes to safety, this can be a big problem. It's easy to think too quickly and jump to a conclusion that turns out to be wrong. And jumping to the wrong conclusion can lead to an incident. Many of the major incidents suffered by our industry were the result of the wrong decisions, made too quickly. Critical tasks shouldn't be done using our fast-thinking brain. We have to slow down, use our experience and knowledge so we make the right decision. In critical situations, we need to slow down and take time to think. Challenge our quick-thinking brains. We need to be sensitive to the signals that tell us things might not be going as we expect, and then take action. And that's a big part of demonstrating our chronic unease. Mind traps, or biases, are traps we all fall into when we're thinking quickly, especially when we're thinking about more than one thing at a time. The first trap is we don't see everything that's in front of us. In a famous experiment, people were told to watch a video of two teams playing basketball. One wore white and one black. They were told to count the number of passes made by the white team. The clock started running, and people focused all their attention on counting the passes. Once the video was over, they were told to relax and watch the video again. A woman in a gorilla suit had walked through the middle of the action, and no one saw her. What we see is not all there is to see. We're also too optimistic. We often believe we can carry out a task far quicker than we really can, and that leads to time pressure, which leads to mistakes. Uneasy people give themselves and their teams enough time to carry out critical jobs. We also get used to risks. Sounds strange, but we do. We're told something might go wrong, and when it doesn't, over time, we stop being careful. Psychologists call it risk normalization. Just because the lion tamer puts his head into the lion's mouth 1,000 times doesn't mean that one day a lion won't bite. And we suffer from confirmation bias. Our fast-thinking brain will make a decision and only then look for facts to back it up, often dismissing facts that don't fit. For example, if we believe the process is stable, we ignore an unusual meter reading. We assume the meter is broken. In critical situations, uneasy people will use their slow-thinking brain. They get the facts first and then come to a conclusion. They don't simply dismiss unexpected data. Inspection reports that are too clean, with identical ticks, make uneasy people suspect that someone hasn't been doing their job properly. Chronic unease is about never assuming that all will be okay, just because all has been okay up to now. Uneasy people are safer because they recognize weak signals and aren't afraid to do something about them, even if it means raising a false alarm. They don't take critical decisions for granted and never jump to conclusions. They get the facts first, and they don't get complacent about risk. They think things through thoroughly, slowly, realistically, and then they act. Chronic unease sounds painful, but it can be very healthy for you, your colleagues, our industry, and the world. Be alert to weak signals and take time for safety.